Welcome to The Explainer. Today, we're cracking open one of the most uncanny, spine-tingling experiences known to human psychology. I'm talking about that sudden, dizzying sensation when the present moment feels like a rerun. For centuries, this whole phenomenon was cloaked in mysticism, ghosts, past lives, but we're going to strip away all that paranormal stuff and look at the actual, literal, neurological wiring behind it. Because, well, as it turns out, while we've mapped out exactly how this glitch happens in your brain, some of the anomalies remain profoundly, terrifyingly unexplained. I want you to really think about this for a second. Have you ever walked into a completely new room, maybe in a city you've never even visited, and felt absolutely undeniably certain you've been there before? Or even crazier, have you ever known exactly what was around the next blind corner before you even turned it? It's deeply unsettling, isn't it? It's this feeling of suspense, almost dread, because your rational mind is screaming that it's impossible, yet your senses are just insisting it's true. Okay, let's dive into this and move straight into the hard science. So the overarching term for this, as you probably know, is déjà vu, which is French for already seen. The phrase was actually coined by a French philosopher named Émile Boirec way back in 1876. By definition, it's a transient, spontaneous sensation of false familiarity. But the absolute key to this entire phenomenon is that second part, the built-in paradox. You feel completely certain you've lived a moment, while simultaneously knowing it's factually impossible. You're holding two completely contradictory realities in your head at the exact same time. Now, this paradox actually has a physical address. Notice the brain scans here. See those areas lighting up deep within the brain? That's the medial temporal lobe, buried deep inside each hemisphere. This isn't just a fleeting thought, you know? It's a physical event happening in a highly specific region of your neurological hardware, an area that's primarily responsible for how we process memories and spatial awareness. To understand the glitch, we really have to understand how the machine is supposed to work. When you process a brand new experience, your brain is actually running two distinct streams of information perfectly in parallel. On one side, you've got the familiarity stream, which scans for patterns to see if you recognize a situation. And on the other side, you've got the contextual retrieval stream, which is responsible for fetching the actual specific memories and details. Normally, these two run side by side, perfectly hand in hand. But what happens when they don't? This quote perfectly captures the breakdown. Think of it like a film where the audio and video go slightly out of sync. When those two streams fall out of step, a region in your medial temporal lobe called the rhinal cortex just goes a bit haywire. The familiarity signal gets processed a tiny fraction of a second early. It arrives before the context can even catch up. So your brain gets bombarded with this loud signal of, I know this, but without any actual memory attached to it. And your brain, it just fills that gap with the closest available explanation. I must have been here before. But why doesn't our brain just fully buy into the illusion? Why do we feel that sense of dread and awareness? Notice the prefrontal cortex in the scan, the area right at the front. This network acts as your error monitor. It's the part of you that goes, wait a minute, this familiarity does not make sense. It flags the out-of-sync mismatch between the temporal lobe's false signal and your actual memories. And that conflict right there is exactly what creates the distinctive self-awareness that something is just wrong. All right, moving on to the Gestalt familiarity hypothesis. Now, see how this builds, because a processing delay isn't the only trigger. Sometimes it's driven by entirely buried memories. This brings us to a fascinating little subregion of the hippocampus called the dentate gyrus. Its entire job is to distinguish between similar experiences. Imagine you walk into a stranger's living room. You've literally never been there, but the spatial layout perfectly matches the layout of a childhood friend's house you haven't thought about in 20 years. Your dentate gyrus detects this structural overlap and fires off a familiarity signal, but the actual memory stays totally buried. You get that eerie feeling of knowing a place without knowing why. Let's look at decoding the temporal lobe with Dr. Wilder Penfield. To really prove all of this, we have to go back to the 1930s and 50s to a groundbreaking neurologist named Dr. Wilder Penfield. While treating epilepsy patients, Penfield directly stimulated their temporal cortex with tiny electrical shocks, and the results were chilling. He systematically documented that stimulating specific areas provoked what he called illusions of comparison, essentially artificially recreating déjà vu. But here is where the absolute dread sets in. During a 1955 controlled field study at the Montreal Neurological Institute, the raw transcripts reveal something terrifying. Patients didn't just feel vague familiarity. They made specific spatial predictions. They'd say things like, there is a window to the left, it faces a courtyard. And in a statistically anomalous 11% of cases involving sites the patients had provably never visited, their predictions were perfectly accurate. No way, right? Penfield flagged this in an unpublished appendix, noting it was structurally unlike anything his memory-engram model predicted. Mapping the brain's GPS, place, and grid cells. So, if our brains can be tricked like this, how do we actually map physical space in the first place? Well, it comes down to an internal GPS system made of two specific types of neurons. First, discovered by John O'Keefe, we have place cells in the hippocampus. These fire based on external landmarks and visual cues. Decades later, the Mosers discovered grid cells in the anterenal cortex. These fire based on path integration, measuring distances and vectors, completely independent of what you're actually looking at. And this brilliantly illustrates how we map what things look like versus the invisible geometry between them. Check out the geometric hexagonal lattice on the left and the heat map of a rat navigating a box on the right. Those grid cells fire in perfect, repeating hexagonal patterns as we move through an environment. It's literally mapping an invisible grid onto the floor of wherever you're walking, updating your internal metrics in real time. So when you feel an uncanny familiarity with a new room, it might be because the math of your hexagonal grid cells is matching an old environment, confusing your internal GPS. Next up, the flavors of déjà vu. Because the brain is so incredibly complex, this phenomenon doesn't just happen in one way. There are distinct categories. We have déjà vécu, the immersive, full-bodied, already lived feeling. We have déjà senti, a purely internal, already felt thought. But I really want to focus on déjà visité, already visited. This is that eerie place recognition phenomenon reported by an estimated 30% of adults. It was actually documented as a discrete category by Théodule-Armand Ribot back in 1881. And remember Penfield's 11% anomaly? Well, in a 1993 replication published in Neuropsychology, cognitive neurologist John Marshall at Oxford documented 4 cases of profound amnesia patients. Placed in completely unfamiliar buildings, they correctly navigated to exits and functional rooms while denying any knowledge of their surroundings. The accuracy was so consistent that Marshall chillingly noted in his methodology that the result requires either an account of spatial memory we do not have or an account of something else we have no name for. The raw trial footage held at the Bodleian Library has never been publicly released. To ground all this dense neurology into the lived, terrifying human reality, just listen to this quote from a patient in the source material describing an intense episode. It was as if one of my dreams had simply been sucked out of the actual physical environment and set to playing again in every detail. That perfectly captures the dread, the absolute suspense, and the awe of this experience. It's your hippocampus, your rhinal cortex, and your frontal lobe, locked in a spectacular misfire. Which brings us to our final thought. We can describe the misfiring circuitry, the delayed signals, and the hexagonal grids mapping your steps. But we still cannot explain why. For a measurable subset of people, what they predict around that blind corner turns out to be exactly correct. So the next time reality skips a beat, the next time you walk into a strange room and feel that uncanny chill, are you just experiencing a grid cell glitch? Or are you tapping into a mechanism of spatial memory we don't even have a name for yet? Thank you for exploring this with me, and keep questioning what you think you know.